Hello, my name is Hanjun Cho, and this is Physics 2211 Lab 5 Pendulums. The purpose of this lab is to compare two different models of pendulum swing to determine if each of those follows the energy principle or not. One real-life model found on YouTube, where it swings and then eventually it stops, and one simulated model using a simulator I found on Google, and the simulated model continues to swing infinitely. And a little preview of the lab is that the real life model does not follow the energy principle as it slows down and stops swinging after a certain time t. So the only fundamental principles really used in this lab is the energy principle, and we use it by comparing different energy at different points of the video to see if energy stayed the same or has changed. And in the energy principle, we involve potential and kinetic energy, but for the lab I'm doing right now, I'll only be using potential energy. And also, I should mention that although pendulum is a good example of centripetal force is not really involved in the work energy theorem, and that tension of a pendulum, which is a perpendicular force of the pendulum, does not really do work, so therefore it cannot be involved in the theorem. So some initial conditions and assumption includes the following: the Earth and the pendulum is one system, and no external work done on the system, assuming since the real life example are not given any statistics. We have to assume a lot of things. So here are the assumptions. Assume height is 0, assume weight is 0.2, assume the length of the string be 0.5 meters, and this is how the last bullet point is how we will calculate the height for the potential energy. So here are the results of real life model. I compared initial and final energy at first and last amplitude, so I don't have to calculate potential energy since at the amplitude I don't have to calculate kinetic energy since the pendulum is not moving at that instance. So here's the simulation model, and as you can see, compared to the real life model, the difference in energy is really small, but there's only difference because there is human error in plotting data points. So in comparison, both models' position versus time graph follows a sinusoidal pattern, but the amplitude of real life model decreases as t increases, meaning that potential energy is transferred into the surroundings. Simulation model amplitude stayed mostly the same for the entire duration of video. Way less energy change compared to real life model, therefore simulation follows energy principle. Real life model initial energy is bigger than final energy, therefore it does not follow the energy principle, because if the model does follow, it should the total energy, but then in this case potential is the total energy because we're only comparing the amplitudes. If they did not stay the same, then some form energy is transferred to the surroundings and therefore does not follow the principle. So here's a graph from comparison. You can't really tell the difference of the real model decreasing, but there is a slight difference, and you can't really tell because of the scale. Some potential errors include there are non-conservative forces present, such as frictions and air resistance in the real model, that causes the model to not follow the energy principle, and we don't know the length of the string, and to add the height and the weight of the system. Assuming the string length can lead to different position versus time graph, so there's rounding error and also human consistency error when plotting data points. Some additional questions are: what if the real system was placed in a vacuum chamber with frictionless axis? Then real system will not follow energy principle with the absence of non-conservative forces. What does it mean when the real life system does not follow the energy principle? Energy transfers to the surrounding in the form of heat or sound due to external forces such as air resistance and friction. Thank you.